All right. So I'm not going to ask you to graph anything. So the first question, what I want you to find is similar to your homework. Find the amplitude, period, and phase shift. So using this formula, y equal to a sine b times x minus c plus d, or y equals to a cosine b times x minus c plus d. We know that our amplitude, our amplitude is absolute value of a, which in this case is going to be what? What is a?
18.
Yeah, so right here we have the negative 18, which becomes 18, right? So on your whole, on the exam, I expect you to write amplitude equal 18, right? Positive. Don't put negative. Period. I gave you two different formulas for period. No, actually, just one. It's 2 pi over the absolute value of b. So you can look at what's on the x or what's already factored if you want to factor it first. If there's anything to factor, there might not be. Like on this one, there's just a 4 on the x, right? So you could pull the 4 out, which doesn't make a difference. So right here we get 2 pi over 4. The absolute value of 4, which is just a 4. This reduces to pi over 2. What would be the phase shift in this case? The phase shift is the horizontal shifting, which is determined by what's inside the argument of your trig function. It's determined by the c. Do we have a c? It's not there, right? So technically the formula would be c. If it's already factored, you would write the opposite sign c. If it's not factored, you would write c over b, or I think in the notes we used omega or something. Okay. So this would be 0. Or c over but it doesn't matter. If you think of it, if you like the other method from that we wrote down, that's fine. Okay. So if you factor it, just write down c but opposite sign. If you don't factor, you can take the c and divide by that omega part, the the number on the X. So it depends on how you approach it. It's technically the same thing. Any questions on number one? Is that cool? Does it make sense? Let me know. That's what we're here for. Given the following, find the amplitude, period, and phase shift. So our function f of x is equal to 12 sine of 4x minus 2 plus 3. We'll go ahead and add what's the other thing? Midline, right? From the homework. All right, first thing, amplitude. Formula is this. What is our amp? Yeah, it's gonna be 12, right? Absolute value of 12 is 12. Okay. Period. Period is 2 pi over absolute value of b, or omega, whatever. What is our b? Yeah, it's just going to be the number on the x. So similar to the last one. Pi over 2. Now phase shift. This is when you need to decide. Do I factor first or just use that other formula? Apparently it is not factored, correct? So I can't write down the c. I can just take the c. It would technically be the opposite sign, so it would be c over b, which would be 2 over 4. Okay. If it was plus, you would use minus 2 over 4. If this was a plus 2, so it's always opposite. Your c will be the opposite of whatever we're dealing with here. Okay. Midline. What's the midline? Yeah, but we have to write as an equation for a line. So write y equals 3. So this is the equation for a horizontal line. Okay. If you write just 3, is technically wrong. This 3 is a value, it's not an equation of a line. Okay, so make sure you write the y. Any question number 2? Make sense? So that's the type of stuff I'll ask for graphs. I'm not gonna go much deeper than that. If you can find these 4 things, you should be good. Okay. Make sure you review tangent, cotangent. They have different formulas for periods. May ask about them, but for sure sine and cosine. It depends on if I have space, because we only have about an hour and change, so I have to be very careful. Otherwise, it's too long. So I might cut something. But I'm trying to cover all the topics right now in the review. Okay. Let me turn the page in a second. Let's move on to 6.3. 6.2 is again is just the same stuff, but for secant, cosecant, cotangent. So I'm gonna move on. No rush. You guys still writing this or? Okay. Oh wait. Anyone lose power during the freeze? No. That's good. One of my friends in Austin, they lost. They haven't had power for like 30 hours straight. It's like sucks. And then a branch fell in front of his garage, so he can't get out. He's just stuck in his house. Man, that's horrible. When we had that freeze 2 years ago, all my pipes froze, so I had no water, and there was no electricity. It was like off and on, so I started like melting snow in order to flush toilets. And then I traded with a neighbor. I gave them starter logs to get packs of water. It's a weird time. Weird time. This time, no. This time it flickered off and on, but didn't lose it this time. Thankfully, but I did burst a bunch of pipes 2 years ago.
That was bad.
Yeah. I think everybody bought generators after that. I want to buy a battery system. They charge them with like solar panels. That way it can just go on indefinitely. That's the goal. But it costs too much money at the moment. All right, let's move on to 6.3. So I may have some basic questions like this. Find the exact value. Meaning, again, if you see that word, don't use your calculator, right? I want to see the actual exact solution. If you just give me a decimal answer, it's going to be wrong. Okay. Use your circle. Or draw a triangle. Those are the methods I want you to use. For this one, you would simply use your circle. You have to remember, so on your formula sheets, remember you're allowed one page, front and back. That does not include unit circle. Put the range and domains for all the inverse functions on it, right? Because inverse sine is defined on a certain half of the circle. So sine inverse of square root 3/2. Yeah, what is the output going to be? When you look at that circle, you have to be going from 0 to 90, or 0 to -90, or pi/2 negative pi/2. You can't choose anything outside of there. It's going to be what? If we do degrees, it's 60, right? What about cosine 1/2? Cosine inverse is defined on the top half of the circle, 0 to pi, 0 to 1/8. So nothing outside of there should you choose. Well, let's make it more interesting. Negative half. Yeah, you're right. I think it is 60. 120. Tan inverse. That's square root 3. Okay, so this one you kind of have to figure out, all right. Tan inverse has the same range as sine, except you cannot include the endpoints. For it to be just square root 3, you would have to divide by root 3 over 2 over 1/2, because the 2's would cancel. So choose the one that has a sine of square root 3 over 2. Okay. So basically what I want you to picture whenever you see these root 3's is I know that this would cancel, leaving me with this, right? So which angle would give me a sine over cosine? Because that's the definition of tangent, sine over cosine. Where would this happen?
60.
Yeah, 60. Because it's not obvious when you first see this. It's like, okay, what the hell is that? But if you remember that this is technically, this came from these two angles, or these two values. And if you see something like this, if the 1/2 is on top, then you end up with 1 over root 3, which rationalizes into this. If you see one of these, then it has to be the sine value of 1/2 on top. Okay, does that make sense? That kind of helps you figure out, all right, by looking at it, I know this has to have that y value on top. The sine value has to be this. If I have one of these, then that means the sine value has to be 1/2. So that kind of points you in the right spot on the circle. Okay, does that make sense or no? I know tangents are weird. It's a little extra step. Anyway, any questions on A, B, or C? Can you use the circle? Is it doable? All right.
You said that we put in right formulas on that sheet.
I mean, if you need that much space, you can, but you have one page front and back plus the circle. I mean, I think that's enough. But if you want to add more, the back of the circle or on the circle, sure. I don't think we have that much information yet, but it's up to you. Just don't put any examples. Just formulas, notes to yourself. That's it. Definitions. Two. Cosine of tan inverse of x. Okay, for B will be secant. I'm sorry, sine of secant. Of x. Do we do this? Well, no, probably not. Be two separate questions. So for part A, remember we said step 1 is let theta equal to that inverse part, right? But then use a definition. This means that tangent of theta is equal to x. That's what this implies by definition. Once you have this, you build your triangle for part A. Put your theta where you want. This will give you opposite over adjacent, right? X over 1. There's always a 1 there. Solve for hypotenuse. A squared plus B squared is equal to C squared, so the square root of those two sums would be this. 1 squared is 1. X squared is X squared. So now we can answer the question. Cosine of tan inverse of X is equal to cosine of some theta, which we defined here. So cosine would be 1 over hypotenuse, adjacent over hypotenuse. I showed more steps in the homework exam or the in-class examples, but is that okay? You remember? You will for sure have one of these types. Part B. That's cool in part A.
How to do it different one.
If you remember, the Pythagorean is this, right? So we get 1 squared plus X squared equal to C squared. So C is equal to the square root of X squared plus 1. You can put them in any order, the 1 or the X first, doesn't matter. But 1 squared is just a 1. So that you don't have to write that. Okay. Part B, sine of secant. So again, step 1, let theta equal tan. So then use the definition. Tan of theta is equal to X. Build your triangle. I'm gonna erase this.
But then it's supposed to be something.
Oh yeah, I don't know why I did that. Thank you. Yeah, the sad part is I don't wake up till the end of this class. So I'm a night person. Secant theta is equal to X. Build triangle based on this. So what is secant? Defined as in terms of triangles. I don't remember. Figured it out though. Would be hypotenuse over adjacent, right? Don't you guys have on your notes somewhere? So there's technically a 1 here. Hypotenuse over adjacent. Solve for the side. Pythagorean theorem. Once you do your Pythagorean, you would get x squared minus 1. I don't have space, so if you want to see this, I'll do it on the board later. Okay, so final step. Sine of secant is equal to sine of theta by our little definition here. So sign would be this. That's what they want. They want, what is the sign given this information? That's so, that's at least that's how I think about it. Any questions on part B? Is that okay? You comfortable with finding this side on your own? You want to do it on the board? Okay, just let me know. I'm not gonna make you rationalize this. I'm sorry.
How do you get the?
Oh, yeah, sure. So we have C, right? C was X. Okay. We have one of the legs. Is 1. Find the missing one. Back the 1 over. Since square root of both sides. You'll end up with this as your missing side. It doesn't matter which one you call A or B. What matters is which one is the hypotenuse, right? Because that's unique. Okay. That's the wrong one. There it is. Okay. I think we covered everything. The last thing I might mention is terminology. Like, if I ask you to find the terminal angle or reference angle, do you know what I'm asking? Right, terminal is where it lands. So the coterminal angle of whatever question I give you. So if it's like, I don't know, the question says find terminal angle of 1,000, you would subtract 360, right? Using a coterminal angle. But terminal meaning where you land, the final spot, not those extra revolutions. We mentioned exact values. Yeah, I think we covered everything. I think that's the only thing missing. You guys have any questions or concerns for exam 1? Did you have any issues with the homework? Get it all done? I hope. I think it's closed now, right? Let's do a couple of practice problems and we'll call it a day before you leave. Number one, find a terminal angle, terminal and reference angle of 1080 degrees. Number two, find the exact value of all 6 trig functions at, I don't know, pi over 6. Find the amplitude, find the period vertical and horizontal shift of y equal to -1/4 sine of 4x plus pi over 2. Find sine of tan inverse of x. We don't have a lot of time, so when you finish these, we'll call it a day. And if you feel like those are easy, then I guess you're ready for Friday or Monday.